And it works when dividing with a polynomial. So what we did, once again, we set it equal to 0 since it's synthetic division. We get the x, -2, that's what we divide by. Set our terms, multiply and add, and we end up with this, and it is a polynomial. So that's how we get that using synthetic division. Once again, you can use it pretty much any time unless they specifically want you to use long division or something else. But if not, you can go ahead and use that. Question 6 says, explain real roots, rational roots, and non-real roots. So we're going to be learning about real roots, rational roots, and non-real roots. This one's kind of tricky, but we can get to it. So we're going to have to look at real roots, rational roots, and non-real roots. Another word for roots is just basically a 0. So to understand this, I'm going to do it a little bit different. I'm going to be using a polynomial as an example, but just the way a polynomial is structured, not a real polynomial. So this is what I'm going to be using. Ax 7th plus bx 6th plus 6x 5 plus dx 4 plus ex cubed plus fx squared plus gx plus h. I know it's pretty long, but don't get scared. It's just, I thought this was the best way for you to actually understand real roots, rational roots, and non-real roots. So, just in general, the total amount of roots that we can have is 7. We get that from our highest exponent. So, just in general, the number of roots we can have is 7. You know that right, top of your head. Now, to see the real and the non-real roots, we're going to make a table. So one side is going to have real, one side is going to have non-real. So it's only going to go up to 7 because we know that we can only have up to 7. So we're going to have 7, 6, 5, 4, 3, 2, 1. And to get the non-real roots, we add this number. We add the real and the non-real, and we have to get 7. So 7 plus what equals 7? 7 plus 0 equals 7. 6 plus what equals 7? 6 plus 1 equals 7. 5 plus what equals 7? 5 plus 2 equals 7. 4 plus what equals 7? 4 plus 3 equals 7. 3 plus what equals 7? 4 plus 3 equals 7. 2 plus what equals 7? 5 plus 2 equals 7. And 1 plus 6 equals 7. So we have our table there. And now, the ones that are real roots, they have to be even. So in order for it to be a real root, it has to be an even number. So 0 is right because that's a 0. So we know that this one works. A 1, that is not even, so that is a non-real root. A 2, that's even, so we know that a 5 is a real 0. A 4, a 3, that's not even, so we know that that's a non-real root. The 4 is even, so we know that a 3 is an actual 0. The 5 is not even, so we know that that's a non-real root. And the 6 is even, so we know that the 1 is an actual 0. So the real roots are 7, 5, 3, and 1. The non-real roots are 6, 4, and 2. And the way we know our actual overall root is by looking at the highest degree. So that's how we got that. Once again, our real roots or zeros are 7, 5, 3, and 1. And our non-real roots are 6, 4, and 2. We got the highest number of roots by highest degree. Now number 7 says, what is the greatest possible number of turning points, relative extrema, and degree? This one's really fun too. So we're going to get started. So we're looking for the turning point relative extrema and the degree. So let's begin by writing out our function that was given to us, which was 4 x fifth plus x cubed minus 3x minus 1. So let's get started with the degree. The degree is the easiest thing you can find. The degree means literally the highest degree, the highest power. That's always going to be the degree of the function. So this one has a 5th degree because the highest power is a 5. Now for the turning point, the turning point is always 1 less than the degree. It's always 1 less than the degree. 1 less than the degree. So that is 4. That's 4. As for relative extrema, well, there's only one way to know. We have to graph this. So if we graph this, we get this equation. We get this graph. Sorry. And there's an absolute minimum and an absolute maximum. So this one does not apply, because when we're talking about relative extrema, we mean something like this, for example. I'm going to go more into detail later, but say you have a graph like so. Well, we know that absolute means the absolute highest, the absolute maximum, or the absolute minimum. So here we have your absolute minimum and we have your absolute maximum. And we see this a little point just right below it, but it's also a max, but it's not the highest. That's when we're referring to relative extrema, because it's not the highest, but it's relative because it's like right underneath the absolute. So once again, to just go over it a little bit, the turning point, relative extrema, and degree are very simple. The degree simply means the highest exponent of the equation. the degree has this function has a fifth degree. The turning point is always 1 less than the degree, so it's 4. The relative extrema is the one that's right below the absolute max or right below the absolute minimum.